What makes this product actually unique is how it fits into the circular economic model for recycling plastics. By recycling them into products like these, you extend the lifespan of the products, the recycled products that you're coming up with, which is a huge gain in sustainability.
Providing a way of taking a waste material and turn it into a resource that you can make useful things out of is an incredibly sustainable thing to do. It's a pretty amazing material, really. It's incredibly tough.
After running some tensile and flexural tests in the lab, we recognized that after failure, it's able to actually take on about 30% more of the maximum failure load.
So this has been fractured, and yet it's still, you know, it's tough enough that it's still a solid material. So it's got very high toughness. It's difficult for cracks to propagate across it, which is a very interesting property. Actually, it's not a material, it's a whole class of materials, really. You can vary so many things here to give you a whole range of different properties. And not only engineering properties, but of course the aesthetic properties, what this material looks like. And that's also a very interesting thing, because it's quite an attractive looking material if you make it in the right way.
Its great asset, which I've thought about as well, is that you can change its colour. In terms of use, appearance is crucial, and being able to change its colour is one of the things that really is useful in architecture, because you want it to go with lots of other things. So if you have a material that can be adjusted to suit the other materials you want it to go with, that's really an advantage.
Aesthetics is a very important part of sustainability. If you're able to factor in, the taste of the consumer in your design, then they are going to use it.
Because it's lighter, you would make a saving on the road transport. It's good for the installers and for the guys working in the factory if it's less weight.
So first of all, the material is readily available. It requires very, very low energy input in comparison to the high temperatures that are required for producing products like cement alone is a big gain. Say in concrete production, you need a curing period in order to attain the maximum strength, which sometimes goes up to about 28 days. But for this particular product, within 2-3 hours, you've already attained the maximum strength for whatever you want to use it for. I would say that the third thing to talk about is the absence of water in the process, which is very, very, very good. So in producing these materials, water is not used at all.
Architects had a bit of a love affair with plastic in the 60s and 70s. Being able to collect all the waste plastic in the world and turn it into something which could be reused is a very beautiful idea. If it really can do all those things, then it's a very interesting material.